We're now going to look at solving a system of linear equations by using the elimination method. The elimination method focuses on the idea that if I have two sides of an equation that are equal to each other, and then another equation where two sides are equal to each other, then we can add the left side of these equations together to get a plus c, and also add the right-hand side together to get b plus d, and those two things will also be equal to each other. Since we're essentially adding these two equations together, the elimination method is sometimes also called the addition method. When we add the two equations together, we do so in a way that one of the variables gets eliminated. And so what we might have to do first is to multiply both sides of one of the equations by a constant value so that when we do add them together, one of the variables is going to cancel out. We end up with a single equation, and this single equation should only have one remaining variable. And then we can solve for that variable. So let's take a look at this example. We have a system of linear equations, and let's notice that right now what we have are two equations that contain two variables. And what we want to do is to merge these two equations into one in such a way that only one variable remains. So we'll start by picking one of the equations and multiply both sides by a constant so that when we do add these two equations together, one of the variables is going to drop out. And let's notice that if we multiply the bottom equation by a positive 4, my y variable will be negative 4y, and that'll cancel with positive 4y when these two equations are added together. So when we multiply the bottom equation by 4, we get 4x minus 4y is equal to 16. Remember, this 4 has to be multiplied by every term on both sides of the equation. And then let's just copy-paste the first equation because we didn't do anything to that. Now essentially we're going to add these two equations together. And we do that by combining like terms. So on the left-hand side we have 2x plus 4x, which is 6x. And this is what we wanted to happen. We wanted one of the variable terms to drop out. 4y minus 4y is just 0. Then we have equals, and then 5 plus 16 is 21. So we've just completed the first two steps. Now we want to solve this resulting equation for the variable that remains. So we'll divide both sides by 6 to get x is equal to 21 divided by 6. And 21 and 6 both have a factor of 3, so this is going to simplify down to being 7 halves. And what we now have is the x-coordinate of our ordered pair solution. To get the y-coordinate of the ordered pair solution, we'll take the x value that we found and plug it back into one of the original equations and then solve for y. And we can really choose whichever one we find to be easier. I'm going to plug it back into the second equation because those numbers are smaller. So back into the second equation, we have the x that we found minus y is equal to 4, and now we need to solve for y. So we subtract 7 halves from both sides. On the left-hand side, we have just negative y. In order to subtract the right-hand side, we'll need to rewrite 4 as 8 halves. 8 halves minus 7 halves is positive 1 half. And then when we divide both sides by negative 1, we get that y is equal to negative 1 half, and that's going to be the y-coordinate of our ordered pair. So this ordered pair solution should be the intersection point between these two linear equations on their graphs. And let's use the graphs to check our answer. This time we'll use a graphing calculator to graph and check, which means that we'll have to solve each of these equations for y. So we'll start off with 2x plus 4y is equal to 5. We want to solve this for y. So we'll have 4y is equal to negative 2x plus 5. And when we divide both sides by 4, we'll get y is equal to negative 1/2 x plus 5/4. In the second equation, we also need to solve for y. We'll start by subtracting x from both sides. So we get negative y is equal to negative x plus 4. And then when we divide both sides by negative 1, we get y is equal to positive x minus 4. So these are the two equations that we'll plug into our calculator. We will go to y equals and enter both of these equations in. So we start with negative 1/2 x. I'm going to go negative 0.5x plus 5/4. And then the second equation is going to be x minus 4. So we've entered in both of the equations. Then we hit the graph button and our lines are graphed here. In order to verify this intersection point, we'll need this calculate function here, which is above trace. So we hit second and then trace, which accesses the calculate feature, and the function that we're after is the intersection. So we can arrow down to number 5, or we can just hit the number 5. Either way, it'll access the intersection function. And then we're asked to determine which two curves we want to find the intersection between. So is this the first curve? We say yes by hitting enter, and it automatically jumps to the second line and says, is this the second curve? Of course it's a line, but the calculator just says curve every time. And we say yes by hitting enter. And then we're asked to move our cursor towards the intersection point that we're after. It doesn't have to be perfect. I'll be visibly off the intersection point to show you that it's okay to just be close. And then we'll hit enter again, and it says that the intersection point is 3.5 and -1/2. 3.5 is 7/2, -1/2, so our answer is correct.